Welcome to episode 2 of this Hoku tutorial series. In the last episode, we talked a little bit about how the software works and we went over the UI or user interface. In this episode, we're going to create our first job and do triage of our multispectral bands. Triage means to look through each of our images and take notes on the characteristics and features in them. To do that, we need a read stack and show module. Move them closely together so they connect with this line and node. The show is pretty self-explanatory. It will just show us the input that we give it, in this case, the read stack. Read stack just reads in our images or files. If you want to know more about what a module does, you can click on it in the cupboard. Read stack reads in multiple images. Show creates a window in which the input image will be displayed. There's a bunch more information in here. A lot of technical stuff about the input type and output type. If you want to learn more, click on the module to get an explanation. Now you'll see the read stack module is outlined in red, while the show module is outlined in green. That means we need to give the read stack more information in order for it to work. We can click on the read stack module and you'll get a new window. At the bottom, you have a question mark, which just pulls up that same explanation you get from clicking on the module in the cupboard. You also have 3 different fields: file names, window, and calibration. In any module window, you'll have some required fields and some optional fields. Required fields are always above this line, and optional fields are always below this line. So in this read stack, we can just look at this file names field. This is where we'll input all of the images that we want to triage. So we'll click Add, navigate to the folder where your flattened images are, and select all of them. Click Select, and you can see it puts all our images into this box and checks the file names checkbox. We can close, and you'll see the read stack module now turns green, and that means it's ready to go. I want to point out that the checkbox is necessary for the module to recognize the information that you've put into that field. So if we uncheck the box, you can see that the read stack turns red, even though we have all of our images here. So make sure the box is checked for every field that you've put information into. We now have a completed job. This read stack will take in all of our images, send them to the show module, which will then show them to us. This job here is comprised of only an input and an output module. Input modules are where you will always give the images that you want to process, and output modules are how you will see or save your results. Read stack and show are the input and output modules that you'll be using the most. All of the other processing that you're doing will come from modules that you put in between the two. To triage our images, all we need to do is see them, so a read stack and a show module will suffice. With our completed job, we can close it by left-clicking and dragging a rectangle around the modules, and then we can right-click and execute it. Whenever you execute a job, you will get a status window which shows you the progress of the job. And you can see our output, the show module, is creating a window for us where it will display the input, the images we put into the read stack. Depending on the complexity of the job and the device you're working on, jobs can take anywhere from a few seconds to a few minutes to even a few hours to complete. This one is pretty simple, so it'll only take about 30 seconds. And there we go. Our job has completed and we can see our images. There's a lot more going on in our show window. The first thing I want to talk about is this image that you're seeing here. This is a pseudo-color or fake color image. To make a normal looking color image, you would put the red, green, and blue bands into the red, green, and blue channels of a 3-band image. This image is a composite of 3 different bands from our stack, so that's why the colors are messed up. This image does not exist outside of Hoku. This is just a tool for displaying images, and we'll utilize this later on for improving legibility. But for now, just know that this isn't something you have to triage, and it doesn't exist outside of Hoku. Moving to the bottom right, you can see we have band showing. This is where all of the different bands you put into your read stack are shown. So if we move the slider to band 0, this is the first band that we have in our read stack module. Right here, our 01 M0365 UV. Hoku starts band numbering at 0, and you can see we don't start with 0 in the file names, we start with 1. This means that the numbers in the file names do not correspond to the band numbers according to Hoku. For me, all of my bands are ordered numerically, so I can just take the number in the file name and subtract 1 to get the band number according to Hoku. So this would be band 41, this would be band 40, 39, 38, etc. Your reflectance images will probably be ordered numerically, so you can subtract 1 from these file names to get the band number, but after the reflectance images into the fluorescent images, your file names might not be ordered numerically anymore, so just be aware of that. To further explain this point, if this number here was just any random number, say 24, this would not be band 24, this would not be band 23, this would actually be band 38, because this here is band 41, 40, 39, 38. So you're always counting based on the position of the band in the read stack module. You're not looking at the number in the file name. So I'll change this back to 39, and now we know which images our bands are down here. So this is band 0, our 01 M0 365 ultraviolet, and so on. Next to the band showing, we have the window box. This is where you will be creating and saving your windows or regions of interest. I'll talk about creating these in the next episode. You don't have to worry about this right now. The history button gives you the job that you use to create that output. So you can copy it back to your desktop and you have the job here again. If you accidentally delete or lose the job that you used, the history button can recover it for you. Under the history button, you have bands. This will just tell you which band you're looking at. This is useful when you're in between band numbers here and it's hard to see where you're at. You can click it to see band 8. When you're looking at a pseudocolor image, like we are here, bands will tell you which bands you are seeing, which bands were composited to make that pseudocolor image. Under bands, we have pixelated and smooth. These are two ways that Hoku displays your images. If we zoom in, we can see the difference here. That's pixelated. This is smooth. I don't often use this. I'll just keep it on pixelated. In the top left, we have an images tab. This is the same images tab in your main Hoku interface. Images, you can see here is our image window. You can close, you can rename. I'll just call it Triage. If you had multiple image windows open, you could click between them using previous and next. If you were switching between two image windows, you could click linked to align the images so that they would be easier to compare. Because I have only one image window open, these don't do anything, and neither does linked. When I have multiple images open, I will show you that. We now know what we're looking at here. We now know what everything in the show window does, and we can start triaging our bands. So triage, like I said, just means to look through each band and take notes on the features and characteristics in them. What we're focusing on here is something called signal-to-noise ratio. Signal is what you're trying to see or read in your image. So for my manuscript, I'm looking at this undertext, which you can see in the margins. This would be my signal. Noise is everything else. So that would be the overtext, the parchment. If you have damage on your manuscript, like fire damage, water damage, or stains from chemical reagents, this would also be considered noise. Noise also applies in the traditional sense. If you think of TV static, noisier images will be more difficult to see. It will make your signal more difficult to read. When you're doing triage, you want to make notes of the visibility of all of these different features on your object. So I'll be taking note of the darkness of the ink of the undertext and of the overtext, how contrasted it is with the parchment, how noisy the image is, and if I can see any other features. Anything like that you want to identify and note down how it appears in each band. So starting at band 0 here, you can see my undertext is quite dark. I can pretty easily make out the letters and words here. However, the overtext is very dark as well. And in my case, my undertext not only runs parallel, but is actually directly underneath the overtext. So that will always make it very difficult to read, but it's still very dark and we can make it out very slightly underneath the overtext. For this band, band 0, I would say the signal is very good, but there's also a lot of noise. So the signal to noise ratio isn't ideal. However, I would of course be noting down that the undertext is very legible, because at the end of the day, signal to noise ratio doesn't matter if you can just flat out read the text that you're trying to recover. I'm going to go through my bands pretty quickly here, but be thorough, be detailed in your notes. These will be very useful later on. It's how we will choose bands for statistical and deterministic processing. So we'll go through the bands here, and you can see as the wavelengths get longer, our ink starts to fade out. You can see by band 11 here, our undertext is almost completely invisible. I would definitely be making note of that. And then we can keep going through the infrared, and band 16, all of our text is completely gone. That's very important. I would make note of that as well. There isn't much variation between bands close together in the reflectance images. It's a pretty linear change from band 0 up to around bands 15, 16, whatever your last infrared image is. Going past the infrared into the fluorescent or wheel shots, we'll start to see much more variation. So in these bands here, not much signal, and our overtext is very dark, so these are not great images. The undertext is a little bit more visible here. It's much more visible here. These are better images. Comparing bands 23 to bands 24 and 25, band 23 has less noise, but the text is equally as dark, so band 23 is probably better than bands 24 and 25. Similar stuff here. A lot less noise there, but less signal. Basically no undertext here. Okay, here you go. Here's a very interesting band. You can see the difference between bands 31 and 32. 32 has a lot more signal. The undertext is much darker. The ink is dark and has good contrast with the parchment. But because there is so much noise, of course, the overtext will always make it difficult to read this text, but noise on the parchment also makes it very difficult to read our undertext. So I would definitely make note of that. Similar stuff going on in band 33. At band 34, we get into the transmissive images. These are images where the light comes from beneath the manuscript. These are usually only useful in specific cases because, as you can see here, you're getting the text from the other side of the page. In the longer transmissive images, you'll sometimes see the text that you're trying to recover. In my case, I don't see it here, but take a close look at your transmissive images and they might be useful. Make note of anything you see on them. After my transmissive images, I have raking light images. This is light shown from the sides of the object. You may or may not have these. These aren't very useful for recovering text. They're more there to give a sense of the form of the object. And there we go. We're back to our pseudo-color image. And that means we've gone through each of our bands and made notes on the features and characteristics in them, focusing on the signal-to-noise ratio. Once you've done that, you've completed the first step of triage. In the next episode, we're going to do the second step, which is window or ROI selection. Technically, it's not triage, but it's a step I like to get out of the way now because it's good to learn it and it's easy to do with our images pulled up. So I'll see you in the next episode for window and ROI selection.